How do we represent IPv6 addresses? Well, it's really different than IPv4. And this is where people start to struggle with IPv6. They panic because it's a completely different format. And the addresses are so big because they're 128 bits in length. But don't panic, because once we're done our discussion here, you'll see that it's really not that bad. So first of all, let's start off with the basics of our IPv6 addressing. First of all, it's 16-bit hexadecimal fields. 16-bit hexadecimal fields. So how many 16-bit hexadecimal fields do we need to make up a 128-bit address? Well, 128 divided by 16 bits each would give us 8. So right here, you can see the format is 8 different hexadecimal fields. 1, 2, 3, 4, 5, 6, 7, 8. Now, inside of each of these fields, we have 16 bits. And how many bits make up a single hexadecimal character? So we're dealing in hexadecimal here. So how many bits make up a single hexadecimal character? It's 4. 4. So what we'll have is we'll have up to 4 hexadecimal characters in each of those fields. 4 hexadecimal characters in each of those fields. So hexadecimal characters go from 0 to 9, and then A, B, C, D, E, and F. So 0 in binary is 0, 0, 0, 0. When we're dealing with 4 bits. F in binary is 1, 1, 1, 1. Because 1, 1, 1, 1 in binary, you have your 8 position, your 4 position, your 2 position, your 1 position. 8 plus 4 is 12, plus 2 is 14, plus 1 is 15. So that's why you get 15 as your highest value. So 0 through 15, you have 16 total characters for hexadecimal. 0 through 9, and then A, B, C, D, E, and F. So those are the only valid characters that could be in any one of these positions. So let's look at a complete example of a hexadecimal, of an IPv6 address. So here's our first field. Notice there's 4 hexadecimal characters, 2001, for a total of 16 bits. So if you broke that into the binary, you'd have 0010, 0000, 0000, 0001. That's really what that whole field would look like in binary. So then we get over to here to 0db8, and then 010f, 0001, whole bunch of zeros there, and then 0acd. So notice that in this case, there's no character of the alphabet greater than F. F would be the greatest character we could have. So 0 through 9, and then A, B, C, D, E, and F. And so that is the full address right there. All 128 bits in hexadecimal format. So there's 8 fields, and each one contains 4 hexadecimal values. But we can shorten this. That's right, we can shorten this particular address. How? We can drop our leading zeros. When we describe money in the real world, we say 5 to represent $5. We say 10 to represent $10. If we write it on a piece of paper, it is 5. If we write it on a piece of paper, it's 10, right? It's not 0010 or 0050. We drop leading zeros. That's what we do. We drop leading zeros. So likewise, in this particular case, we can drop our leading zeros. So in this example here, are there any leading zeros in the first field? And the answer to that's no, because the first field starts with 2, right? There's no leading 0 there, so you leave it alone. But look at the second field. The second field starts with 0 and then db8. Well, drop your leading 0. That's right. Drop your leading 0. So now it's just db8. Means the same thing. We get over to this field, we have a leading 0. You drop it, it's 10f. Notice you can only drop the leading zeros. You can't drop any other zeros inside of there. Likewise, look at these. The 3 zeros with the 1. So drop the 3 zeros, you're going to end up with the 1. So the leading zeros in that case is all 3 of them. Likewise, in this field, and this field, we drop the 3 leading zeros, but you have to leave at least 1 0 when you're dropping leading zeros. So I can't get rid of all 4 in this case, in this example right now. But hang on, I'll show you a way we can do that after. So we end up with 0, 0, 0, and then we drop the leading 0 there for ACD. So look at our examples down below. We can see that example number 1 and 2 and 3 and 4 are represented with all of their characters, every single hexadecimal character representing all the bits. But if we drop leading zeros, watch what they look like. There you go. Wow. Yeah, they become relatively short when compared to their original format.